Yep. Hello everyone. Good evening. Good evening, Harini. Good evening, Navya. Good evening, Yash. Hello everyone. So again, a very warm evening to all of you watching the live session. Right. So as we all know, today is the day 3 of the C++ Bootcamp series. Right. So over the past 2 days, we have actually seen a lot, in C++. We started with the installation part, of course, right? Then we moved on to, I think, operators, data types, variables, functions. We have covered pointers. We have covered static memory, dynamic memory. I mean the heap, right? And all these things, right? So I hope all the concepts covered in the past few days or past 2 days is crystal clear to you, right? We also covered arrays in the last class, right? One-dimensional arrays, if I'm not wrong, right? So, with that being said, now today we'll move to a very interesting topic in OOPS, right? Before OOPS, let's cover strings first, right? That was remaining, and obviously 2D arrays. We have already covered what arrays are. That was a one-dimensional array. That was a one-dimensional array, and today we are going to cover two-dimensional arrays, strings, and then we'll move to OOPS. Is that clear, everyone? Right? So are we excited for day 3? Yes or no? Yeah. Okay. So with that being said, let's actually move to what first of all 2D arrays are, right? So uh, yeah. Okay. So yesterday we did cover arrays, right? So again, just like you have, so this was a 1D array. That is a one-dimensional array, right? Similarly, we can also have two-dimensional arrays. How will a two-dimensional array look like? So you'll have, let's suppose I am having a 2 by 2 matrix. So it will look something like this, right? This is two-dimensional array, right? Rows and columns. That means it is a 2 by 2 matrix. That means it will have two rows and two columns. Let's suppose I have 1, 2, 3, and 4, right? So if we had let's suppose a 1D array, and I wanted to access the third element, right? So I would have done like this, ARR of 2, because the indexing starts from 0. That means I'll point to the third index, the third element. Similarly, if here you want to access the values, let's suppose you want to access the fourth value, right? So let's start indexing it first. So obviously the indexing starts from 0. So I'll write 0th index, 1 index, 0th index, and 1 index, right? And obviously I need to refer to this value. How will I do it? I'll do it something like this. So it is ARR. Since it is a two-dimensional array this time, I'll do like this. 2, not 2. The index would be 1, 1, and 1, right? This is how we represent a two-dimensional array, right? So let's also try to code it out. How do we code it? So I'll make a new file today by the name of day 3. Okay, and I'll make the header files, and now I'll write. So I'll say int ARR, and this time it's a two-dimensional array. So right, the syntax would be, let's suppose I'm having 2 rows and 2 columns. You can have 3 rows, 4 rows, 5 rows, any number of columns that you want. It's up to you, rows and columns, right? So I'm having a two-dimensional array, 2 comma 2. equals to, now here I need to specify first row, then column, row, column, row, column. So let's suppose I'm in the first row. So I'll represent, let's suppose I want 1 and 2. Then I want in the second row, I want 2 and 3, right? And as simple as that. That's how we represent a two-dimensional array. And let's suppose I want to access the last value, or the value present at the first row and the first column. So how will I do it? I'll do that by cout ARR of 1 and 1, right? That's how we do it, right? Okay, let's run it now. Let's see. If we run it, we get 3. And why 3? Because this is my array. So how will I represent this? So if we want to see it, I'll show it to you. What does this mean? So if I've done this, this will mean like my array would be something like, so this is 0, 0, right? This is 1. Then we have 2. Then again we have 2. And now we have 3. Right? So the answer was also 3, right? So that's how we can do it. And if you want to access all the values, what you can do, you can loop it around, right? You can loop and you can print all the values, right? As simple as that. Sure? Is this clear? The idea about 2D arrays. Similarly, you can have 3D arrays, you can have 4D arrays, 5D arrays, but not needed. 2D arrays is the, apart from like, it's the max limit, right? 3D arrays are very rarely used. I have not seen people using 3D arrays, right? 1D, 2D at max, right? Is it clear? The difference between 1D array and 2D array, 1D array will only have 1 row. 2D arrays can have more than 1 row, right? 2 rows, 3 rows, 4 rows, up to you. But we usually have 2D arrays at max. We don't go till 3D, 4D, and 5D. Right? Clear, everyone? Awesome. Answer is wrong. How is answer wrong? We are getting 3, right? We are getting 3 here. That means first row and first column, right? Why will the answer be 1? C. If I'm doing ARR of C, if I'm doing 1, 1, that means first index. So if I index it, index number 0, index number 1, index number 0, index number 1, right? So 1, 1 means first row, first column, this column, and this row. That means this index 1, 1. So see, this is 1, 1. This is 1, 0. This is 0, 1, and this is 0, 0, and this is 0, 1. As simple as that. Clear, everyone? That's how the answer will be 3. That means first row, 1, 1 means go to the first row and the first column. So this is the first row, this is the first row, and this is the first column. So this is the value, right? Awesome. Okay. Now with that, let's now get into strings. Very interesting again. Okay. I think you've already done strings, but since it's given here, let's do it again, right? Strings. Anyone? What are strings in C++? What is the use of strings, and what is the difference between a string and a character? Who will tell me? Collection of characters shared by Yesh. Okay, a very solid definition. He says a collection of characters, a sequence of characters, group of characters, collection of multiple characters, collection of characters. I hope like exactly you guys are there. So it means a sequence of characters, a collection of characters, I can say. Let's suppose I want to represent my name here, right? Obviously this is a string, right? This is a string. This cannot be a single character. How is a string different from a character? A character will only store one bit, right? Whereas if you want to store a sequence of characters, then you have to represent it in a form of a string. You can see that in a funny way. You can say that character is singular and string is plural. This is not the exact definition, but just to make you guys understand, singular and plural. Got it? Okay. So how do we declare strings? Again, very simple. So you represent it by like string keyword, string str equals to, let's suppose, in double quotes, right? In double quotes you do it. Let's upgrade. Right? And if I print this out, I say cout str. If I run this out, I get let's upgrade. That is a string, right? String is nothing but a sequence of characters. Again, see, now with this, there are multiple methods that are used with strings, right? And now you guys will say, what are methods? Anyone knows what are methods? What are methods? Methods are there in arrays as well, in strings as well. What are methods? So methods are pre-built functions, right, that are written to ease your programming. Let's suppose you want to, I have a string, let's upgrade, okay, and I want to find the size. Let's suppose I'm stuck in a situation where I want to find the size of this string, right? Now, how would I do it? Let's suppose I don't have access to any of the string methods. How would I do it? Again, very simple. I'll take a count variable. I'll start looping from the 0th index till the last index, and I'll find the count on each iteration. I'll try to increase the count. But the main question here is, as you know, that loop needs to have an ending condition, right? Loop needs to have an ending condition. How will you end it? How will you know that, okay, at this point of time I need to stop? Because you don't have the access to the size, right? You don't have access to the size. Now that's where methods come into picture. Methods say that instead of you doing the hard work, we already have made the code for you. You don't need to explicitly find the logic to calculate the string, the length of the string. We all have it at par. We all have it there, right? So that means that we somehow know where the string is going to end. Otherwise, if we have not known where the string is going to end, there are methods like a slash n. That means that is the ending part of the string. That means you have to calculate the length, right? You have to calculate. But why follow the naive approach if things are already given to you, right? So that's how we do it. Now, let's look at some of the most widely used methods in strings, right? And first one, as we have already wrote in the chat box, to calculate the size, right? So let's calculate the size. What is the size? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? Now let's try to calculate the size. To calculate the size, there is a method called as dot size. So if I do str dot size and then run the code, right, I will get the size here. As you can see, I got 10. That means it is the length. It is the length of my string, right? Similarly, you also have a way to concatenate. Since let's suppose I have two strings, string str and string str1. It says hello. Now I want to join two strings, right? The first way is, what do? You just print, or you say string result equals to str, right? That's how you represent it. Then you need some space in between to distinguish between between both the strings. Then you need str1, and then you finally print it. Cout result, right? See out result. And now if you print it, we get the concatenated string, right? We get the concatenated string. Yeah, right? Similarly, you also have an append method. You also can append it, right? You can also use dot append method. You also have dot append method, right? There are multiple methods for that, right? You even have a method to sort the strings, right? Multiple methods. Acha. Now let's suppose I want to only print the letter E, right? I only want to print the letter E. How would I do it? Just like we do it in arrays, right? How is that? Let's suppose I want to print the letter E. I'll say cout str and the value present at the, so this is the first index, right? In strings also there are indexes. So this is will take a format of index. L will be 0th index, E will be first index, and so on and so forth. Okay. So I can say 1. This will give me the result E, right? And alternately, let me also remove this. Yeah. Alternately, you can also use caret property. So there's a property called at caret. It will give you the element present at the first index, right? So alternately, we have the char at method, right? And so it's similarly, see, there are ample number of methods. So that's your homework. Just go out, explore all the string methods, try to implement all the methods, try to see what is the result that you are getting, and try to get your hands on with the string methods, right? There are n number of methods available, each serving their own different purpose. Got it? Okay, sure. So now with that being said, let's move to the most interesting topic in C++, and that is who'll tell me? Object oriented programming. Exactly. Oops. Right? And as you can recall, the major difference between C and C++ was the introduction of oops, right? We've been hearing about oops a lot, right? Object-oriented programming. C++ supports object-oriented programming. It supports all the features of object-oriented programming: polymorphism, inheritance, encapsulation, each and everything, right? Now let's actually see what oops are. What purpose do they serve? So there are majorly two things involved when you first do oops. The first one is the class. The second one is the object, right? Acha. Let me start this topic with a question. Okay. Now, let's suppose you are an agency that manufactures car, and you kind of, I would say, you kind of, are associated with the data. You keep a watch that what is the price of this car, what are the features of this car, how would you rate it in terms of NCAP or safety ratings and things like that, right? Again, what is the naive way to do that? So let's suppose you have a vehicle. Let's suppose a Fortuner. Hmm? I would say that it has a 5-star rating, right? Let's suppose the color I want to opt is white, and the brand name is Toyota. It's Toyota, right? If I'm not wrong, yeah, Toyota. Right. So this is car one. Let's suppose another user comes to me, or another detail comes to me. This time, let's suppose I'm buying a Swift. Again, I look at the ratings. Maybe let's suppose Swift is a 4-star rated car. I want to opt for a color black, and the company is Maruti, right? So what are we doing here? For each and every car that we are getting, we are loading all the properties, all the information. So can we say that if I want to make a blueprint, what are the things that are common here? I would say the ratings. The ratings would be there for each and every car, right? The color would be there for each and every car. The brand would be there for each and every car that is made. Getting it? So can I say that what if I have a blueprint? I have a blueprint which contains all these properties, that is rating, that is color, that is brand. And on each new car that comes, let's suppose I get a Swift, I already have the access to these properties. I just need to fill them. Let's suppose rating 5, color black, brand Maruti. I don't need to replicate the ratings, the color, the brand each and every time I write the code. It already, we have a blueprint. It's just like you have all the details, but you just fill in the blanks, right? And this blueprint is called a class. And these properties that are derived from classes, these are called as objects. Class is a blueprint, and objects are the properties of that blueprint. So what are the properties of this this blueprint? Let's suppose this is Swift, right? What are the properties of Swift? It has a rating of 5. It's got a color black. It's got a brand Maruti. That's what the whole concept of OOPS is. You don't repeat the code. If you see that there is some code which will be common for n number of times, you just make a blueprint. And in order to replicate that, you just make an object, you just make a copy of the blueprint and just use that. Right? Is it clear? Is the difference between an object and a class clear? And most importantly, what are classes, what are objects? Is this thing clear? Yes or no? Is it clear, everyone? Okay. Kalyani clear? Yes, clear. Gautam, yes. What about others? Tanu clear. Anyone else? Any doubts? Okay, awesome. Now. This was a theoretical knowledge. Now let's try to implement a class. Implement a class. Right? So don't worry, we'll just implement a basic class that it gets clear to you what exactly do I mean by that. Okay. Now, what will I do here is I'll make. Let me not make a new file. Let me just comment these. Okay. Yeah. So I've already taken a car example. Now let me this time take a class animal, right? An animal would be the blueprint, and types of animal, let's say dog, cat, and giraffe, monkey, donkey. These all will be objects, right? So I'll say class. Acha. To make a class, you have to first write a keyword called as class, then the name of the class. The name could be anything as per you. So I'm writing it animal, ANIMAL, and then not round brackets. These brackets will come, right? Just as you have in functions. Acha. Now, once you write a class, there is something called as access modifiers, right? Now, what are access modifiers? Anyone? What are access modifiers? Those who have done it. Visibility, exactly. Now, again, I'll give you a situation, right? Let's suppose in this class you also have the owner's phone number. Owner's phone number, right? And obviously, I'm someone who's buying a car. I don't want that this phone number should be visible to the public. I don't want that. For security purposes, you can say, right? So, do I have a way to hide this from all the users? I do. And that's where access modifiers come into picture. Access modifiers tell you that which all properties you have the access to. There are majorly three types of access modifiers. One being the private, next being public, and the last one being protected. Now, this one will make much sense to you once we are done with inheritance. So we'll cover this part later, but we'll see the difference between the two for now. Private and public. Right. Now, if any data member, if any variable has a keyword called as private, that solely means that you cannot use it outside that class. Let's suppose I have a class. This is my class animal, and I have a private variable. Let's suppose I have a private variable. It shows the color of that animal, right? If I have a private property here, that means I cannot use it outside the class. Here, color property will not be accessible to me. Whereas if I do public here instead of private, then only I can access this color property outside my class. Getting it? The difference between private and public, as it's very intuitive by the name itself, right? Private meaning private to the class. You cannot access that. Public meaning that it can be accessed all over the globe, all over outside the code. As simple as that. Right? We also see examples, both of them. So let's implement that. Right now, I'll say that, hey, what I'll do is I'll have a public property, right? Acha, that's how you declare access modifiers public, and then these two dots, semicolons. Okay. Now, I have an animal. Let's suppose a function. I can make a function also. See, in classes, I can make functions, I can make variables, I can make anything that I want. So I'll make a function called as void eat. Let's suppose, and if I come to void eat, I'll say, so the animals who can eat, right? I think all the animals can eat, but still, I'll say if I come to this eat property, it says I can eat, right? Acha. Now, an animal that can sleep. So I'll make another function. I'll say void sleep, and this time it will say cout I can sleep, right? Let's have this simple structure for now, right? Now, what has just happened? So this is a class, and also once you end the class, you have to put the semicolon right here, right? That signifies that the class has ended now, right? It's important, otherwise it will give you compilation error. Okay. Now, what is this thing? So if I paste it here, this is a class, right? This is a class. It has two properties called as eat, called as sleep, right? That means that if this is my blueprint, and if I want to make an object of it, my object will have the copies of eat and sleep, right? Eat and sleep. As simple as that, right? Acha. A very good question pointed out by Anubhati Mishra. She says that by default, if I do not have anything here, by default, what will be the value? Will it be private? Will it be public? Anyone on the chat box has an answer to that? Yeah, anyone? Okay, so my question is, Yash, let's suppose if I do not have any access modifier here, in that case, what will be the default value that would be taken up? Is public be public, will it be private? Okay, well, in Java it is default if we not mention. In C++ also it is default. But what is that default value? Public or private? Yes, mixed answers. I think majority of you are wrong here. So the default access modifier in C++ is private. If I don't provide any access modifier, it will be private by default. Yes, Shivam, it will be private. Right. So again, to answer your question, Anubhati, yes, it will be private. Anyways, let's move ahead. Okay, so now this was the class that I made. Now, from this class, I need to make objects, right? From this blueprint, I need to create the actual object which can contain the properties of that class. Now, how do we make an object? For making an object, it's very simple. You write the name of the class. You say animal. The class name is animal, right? And the object name. Let's suppose the animal that I want to see properties are is maybe a dog. As simple as that. Now, in order to call the properties, right? In order to access, so this animal class has two properties, eat and sleep. To assign a property, we use a dot operator. So if I'll say dog dot eat and call the function, this will mean that dog will have the properties of eat. It can access the properties and it can eat something. Similarly, I can also have dog dot sleep. Okay, let's try to see the result as well. So if I clear the console and I print it, see, also let me put an endl here. Okay. Now see, I can see here, it is pretty much visible that I'm getting both the values. I can sleep and I can eat. Now what has just happened here? See, where's that thing? Yeah. So from this blueprint, I made an object. I named it dog, right? And here, since this is inheriting the properties, it will have access to both the properties. It is, since it is inheriting the blueprint of the parent and the parent is this object, this animal object. That means that it will take into account both its properties, right? Now, to access the properties, as I told you, we need a dot operator. We need a dot operator. So if I have a dog and if I want to access its eat property, so since see, one more important thing is, since I've made an object dog, it will have access to all the values in the parent blueprint. So if I want to access the sleep or the eat property, I'll say dog dot eat, dog dot sleep. As simple as that, right? So and if you want, you can also make another object. I'll say animal. I'll say cat, right? Similarly, you can have cat dot eat, cat dot sleep. You can make n number of objects that you want to. As simple as that, right? So that's where oops come into picture. You made a single blueprint, and objects that you make will have the properties of that blueprint, right? Acha. Now in OOPS, there's something called as inheritance. Okay? But before that, let me cover constructors, right? Let me cover constructors. Okay. Now, what are constructors? Nothing rocket science. Constructors are the first instance that are called when an object is made, right? First instance when an object is made. And there's something called as a destructor. Destructor. Destructor means whenever you end the functionalities of an object, right? Last instance to be called when object is made, right? Acha. Let's see how to make a constructor, right? So for making a constructor, it has to be of the same name as the class, right? So, and that is animal. And once that is made, you can write, for demonstration purpose, animal constructor called, right? And what about a destructure? Making a destructure, you have to first use this symbol that is just present on the left side of the key, the number 1, right, on the keyboard, this thing, and you have to call animal, right? And now I'll mention here animal destructure called. Yes, constructor has to be the same name of what of the class plus the destructure, but the difference is it will have this icon. This is a destructure. That means it is destroying the object. Once the object has been made, its role has been uh, implemented, then you read the object basically. I'll show you. Let me comment this out. And interestingly, I'll show you the output also. Okay, so I'll clear out the screen. I'll run the any error. It says let me run that again. Okay, private. Did I mention private here? Oh, okay. So this has to be public because by default it is checking the private properties. So here I have to mention public, right? Now I'll clear out the screen and print the result again. Okay. Now interestingly, when I run my code, the first message that I get is animal constructor called. And that is the exact same thing I told you. Constructors are the first thing that are called when your program or when the object is created. I'll also mention endl here. Right? Now, after the constructor has been called, these are the methods, right, of a class. And as I told you, destructure is the last thing that will occur at the end of the program or at the end of the class. So as you can see, first we have the instructor first instance, Then we have the destructor, that is the second instance. Got it? Just give me a second, please. Everyone clear the difference between constructor and a destructor? All right. Okay. Now let's move to the next thing. And that is a very important pillar of OOPS, that is inheritance. Or that is inheritance. So, as the name suggests, inheritance. Okay. What is this about? I have a base class, let's suppose. This is my base class. Hmm? And now I have some situation, right? Some situation that I want to make another class. And this class has to be the same replicate of the base class plus some new properties. Plus some new properties. Let's suppose this has a property A, this has a property B. Now what do I want here is, I want to have a new class. There are two ways to create a new class. See, one is that I create a new class, I copy the same properties A, B, and then I make a new property, an additional property, that is C. But with inheritance, what you can do is, we'll say that, hey, don't create new properties that were, don't replicate the properties that are already there. You just create properties that are new. So that means only C will be created, but it will have access to both A and B also. And that is inheritance, right? Let's let's suppose a very common example. Hmm? You have parents, right? And you inherit some properties from your parents. It may be the type of face, the hair color, right? Anything, the height, the weight, anything. That means the child has some new properties also. Obviously you have some distinguished properties that your parents don't have, but you also have some common properties. An exact uh, what I say, definition, I would say, of inheritance, right? The most common definition. You inherit some properties, the base properties are also there, but you also have some new properties, right? Now, how to implement this? It's again very, it's a cakewalk journey for you, right? Obviously, yeah. So main reason is being we are able to reuse the code, right? Without even getting to write the old code, we can reuse it. Okay. Now, how can we inherit? So this was the animal class that I've called, right? Now, I'm making a new class. Let's suppose I'll comment. Chalo, theek hai. Class, obviously, how to make a new class, as I just told you. Class, then will come the name of your class. So what name should we give? Let's give a new animal, or animal 2.0, anything of that sort. Animal 2.0. And this class has to inherit properties of the parent class, that is the animal class. So I'll say I have a semicolon, then the access modifier. That is very important, because if you don't write any access modifier, it will be private by default. But I want it to be public. And which class you are inheriting it from? The class is called as animal. Animal. As simple as that. Now you have successfully inherited the properties of animal in animal 2.0. And let's suppose I want to make a new maybe a new feature or a new function. So I'll say public. In public, let's suppose I make a new feature. Let's suppose bark. That means bark. Can the animal bark? Yes or no? Bark. And I'll see out. I can bark. Obviously with an end statement. Acha. Now interestingly, see. Now this time I'll not make an object for animal. I'll make an object for animal 2.0. Okay. And I'll call all the three functions. I'll say dog dot bark as well. Acha. Now tell me, this animal 2.0, right? It only has a single property, that is bark. But what am I doing here is I'm also calling eat, I'm also calling sleep. Those are the properties of the parent class, that is the animal class or the base class. So do you think will this work? Will this work or will this give an error? Anyone? Because I'm creating dog.eat, but eat is not there. I only have bark. Will this work? Exactly, Shed by Anubhuti. This will work as it is inheriting the features of parent class. Although the child class does not have a feature called as eat, but the parent class has one feature. So yes, it will work, and that's where inheritance comes into picture. It will work due to inheritance. If I run the code, okay, we cannot name it number. So I'll write 2 here. It's a naming convention, we cannot name it. So I'll say animal 2 only. Animal 2. Here also I'll say animal 2. Okay. All right. Let me clear the console. And let me run the code again. I missed a semicolon. Yeah. So when we end the class, we have to place a semicolon. And now let's try to run. Okay. See? As simple as that. We are getting all the properties from the child class. All the properties the child class has from the parent class. Right? We're getting eat property, sleep property, and the bark property. Okay, is this thing clear? Is inheritance, how do we use inheritance? Just make a class, a semicolon, the access modifier, and then the new class. As simple as that. Right? Okay. The next thing that comes in OOPS after inheritance is polymorphism. Now this polymorphism you've done it already on day 1, I think, but not by the name of polymorphism. Can anyone tell me by what name did it on day 1? We've already done it to some extent, but not by this name. Let's see who is able to get that keyword that we used on day 1. Exactly, right? Said by Anubhuti. It's function overloading. Remember, everyone, what was function overloading? What is function overloading? I hope you all remember, right? We did it on day 1, I think. Day 1 or day 2. I think it was day 2, if I'm not wrong. Right? Now, you can consider it like function overloading. Same only function overloading. But in a different way. That is in classes. And plus you have to modify that function. Right? You have to also modify that function. Okay? Now, obviously, let's also see an example. So I'll come here. I'll comment these out. So see, this has a function. This has a function. This is the constructor. Sorry. This has a function called as eat. Right. What I'll do here is instead of bark, I'll make a same function eat, and I'll modify it this time. I'll say I can bark plus I can eat. Acha. Now you tell me, if I call dog.eat, what would be my answer? Will it be I can eat or I can bark plus I can eat? Anyone? What will be the answer? Okay, let me just cut the suspense. Let me just show it to you. I'll clear out the screen first. I'll run the code. Let me save the code. Let me clear the screen and let me run the code. Okay, I'm getting I can bark plus I can eat. And why is that? Why are we getting that? Because in the parent function, I only have I can eat. It's due to function or polymorphism. The function name are same, but we are injecting it with some changes. Right? We are making some new changes to the function, and that's it. That's what polymorphism is. And obviously, we are not going into depth. So there are again two types of polymorphism: compile time, runtime. We're not going into depth. It might confuse you, but at this stage, if you know this much, you're good to go. Obviously, you can read about it more, right? Polymorphism, but that's it, right? And the last thing we have is encapsulation. Encapsulation. Acha. Okay, just tell me one thing. We talked about access modifiers, right? And I also told you that if we have any private property, it cannot be accessed by any object outside the class, right? But what if I tell you there is a hack? I'll not say hack, I'll say there is a way to do that. And that is by using encapsulation. Right? Interesting, isn't it? That it is private, but still using some way, we're able to get that. How cool is that? That means you'll encapsulate your code into a single code, and with the help of some function, a getter and a setter function, you can get into that function. Let's not get together theory part. Let's actually implement it, and let's see what actually it has to offer us. So first of all, I'll say, or I'll comment all the part. Right now, so very cleverly, what I'll do, I'll make this function private. Chalo. Right now, if I've made this function private, that obviously means that I cannot access sleep here. I'll also show you, it will throw an error. So if I run the code, see, it will say sleep does not name a type because it does not know what sleep is. It is a private property, right? Now, what I'll do is, see, I told you that private property members cannot be accessed outside the class, right? But obviously, if it cannot be accessed outside the class, we can access it inside the class. So what I'll do here is, I'll make a new function. I'll say void, just get me the sleep value, get sleep. And here I'll call sleep. Okay. Now instead of calling sleep, I'll call get sleep. I'll call get sleep. And this time if I run the code in wait, get sleep is okay. This will be public, obviously. Or let me do one thing. Let me make it here. Okay. Now let me clear the screen and let's run the code again. Animal, okay. Animal also has to be public. So I'll move it above. I'll again clear the screen. I'll again run the code. Okay. At this time, interestingly, the sleep property is private, but I can still get I can sleep. Now, how is that? Isn't that interesting? I would say, right? Isn't that contradicting? Because we only said that we cannot access private properties outside the class, but यहाँ पे how are we able to do it? Right? The reason being very simple. As I told you that if you're having a private property, it cannot be accessed outside the class, but we can still access it inside the class. So what I'm doing is, with the help of this set sleep method, I'm calling the sleep method which is in private. See, this sleep method will have the access to it, right? Because it is in the same class. Right? So what I'm doing here is, see, I'll show you in pictorial way. I have a property called as sleep, and this is private. This is a private property, right? It has a lock to it. But what I'm saying is, this is a class, let's suppose, and all the members inside the class are visible to each other, be it private, be it public, right? I'm making a new function called as get sleep, and I'm saying that, hey, please get me the value of sleep. Now obviously this get sleep can get the value of sleep because it is in the same class, although it is private, but it is in the same class, right? So that's how you're encapsulating both the codes. You're encapsulating it so that you can access the properties of private members as well. It is binding the code. These two codes are binded to each other. If you have to access this code, you have to get through this code. You cannot individually access this code without the use of this getter method. And that's why they are called as getters. They are getting you the value. There's something called as setters as well, which sets the value. And there's something called as getters as well, which get the value. In this case, it is acting as a getter function. It is getting the sleep from here to here. Right? I hope that's clear. All the properties. I hope inheritance, polymorphism, and encapsulation. It cannot be simpler than this. Right? So I hope you really enjoyed it. The OOPS part. In the next class, we'll be starting with the file system, reading input files, and obviously we'll be starting with STL. That is standard template libraries, right? So please give it a good read. Once the class is over, please revise it. If you want to just practice some string methods that I told you as a homework, and we'll meet tomorrow, same time, right? and we'll continue our session. Okay. So with that being said, let's wrap it up, and good night. Good night, everyone.